Hello everyone, and welcome to this video on the Python programming language. So in this video, I will attempt to predict the future price of Tesla's stock using a Monte Carlo simulation, which is a way to model the probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables. Now, I'm currently on Google's website. It is called colab.research.google.com, and I'm on it because it makes it easy to get started programming in Python. So if you want to program along with me, just go to this website and then log in using your Google account to get started writing your Python code. All right. So go ahead and click on File, click on New Notebook in Drive. This will open up a new tab for you and eventually a new cell. And in this cell is where we're going to start writing some code. But before we do, if you like the videos on this channel, then be sure to click that subscribe and that like button. And to be notified about new videos from the channel, hit that bell notification. All right, so let's go ahead and begin. So the first thing that I'm going to do is import the libraries that I need for the program. So I'm going to import NumPy as NP, and then I'm going to import pandas as PD, and then I'm going to import matplotlib.pyplot as PLT. Okay, and then I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistake. So we're going to let it run. And while it's running, if you want to get the code or just the data set in this video or just support the channel, you can do that on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. And the material in this video is purely educational and not financial advice. All right, so let's go ahead and continue. So I'm going to create a new cell by clicking that code button in the top left. And now in this cell, I'm going to get the data set. So I'm going to create a variable called df, and I'm going to set it equal to pd.read_csv. And then we need to give it the name of the data set that we want to read. So the data set name that I have is tsla_data.csv. And so this is going to be a CSV file that contains data on Tesla. I'm going to set parse_dates equal to true. And then I'm going to index the columns to the date. So it's going to be equal to date. All right. So now if I run this, I'm going to get an error. So let's go ahead and run this. And we see that I get an error message. And that's because I have not uploaded this data set yet. So let's go ahead and do that by clicking this folder looking icon called Files. Click that upload button. And I'm going to click on tsla_data.csv. I get a little warning. It's okay. So I'm going to click OK. And now we have the file here loaded. So let's go ahead and run this cell again. And now we see we get a little check mark, so everything's okay. So I'm going to exit out of the left pane. And also here, I'm going to show the data. So I'm going to just type df here, and let's run this. Okay, so now we can see the data set. We have the columns up here, and we have 2,513 rows of data, and of course those 6 columns that I highlighted earlier. And we can see that this data is about 10 years. So from December 5th, 2014 to November 29th, 2024. Okay. All right. And of course, the columns are open price, high price, low price, close price, adjusted close price, and volume. All right. So let's go ahead and create a new cell. And now in this cell, we're going to simulate the future paths. We're going to simulate the future prices. Okay. So I'm going to create some simulation parameters. So first we're going to get the number of simulations that we want. And I'm actually going to set it equal to 1,000 here, like Google suggested. And then we're going to have to create how many days we want to forecast out. So I'm going to do 365 for about a year. So let's go ahead and create a variable called forecast_days and set it equal to 365. Although 252 would probably be more accurate. I have to think about that. There's about 252 trading days in a year. And then there's, of course, about 365 days in a year. But for now, I'm just going to put 365. We're not going to worry about it too much. Let me make sure I put some comments here. So I'm going to put simulation parameters. All right, so let's go ahead and run this cell. It looks good. Let's create a new cell. And now here in this cell, I'm going to initialize the simulation array with all zeros, okay? So I'm going to create a variable called simulations, and I'm going to set it equal to np.zeros, and then we're going to put in num simulations and forecast days. So I'm just going to tab that over just like Google suggested here. It looks good. And I'm going to put in some comments, initialize the simulation array with all zeros. Okay, so let's go ahead and run that. And let's create a new cell. And now I want to get the last adjusted close price. So I'm going to create a variable called last underscore price, and I'm going to set it equal to df. And we're going to use adj close, adjusted close. And then we're going to put -1 here. So we're getting that last value from the adjusted close price. So if I scroll up here, we can see the adjusted close column here, and we should get this last price here, about 345.16. So let me go ahead and add some comments here. Get the last adjusted close price, and then I'm just going to show the price just to make sure we are good. So let's go ahead and run this. All right, and we can see the price here, 345.16. And of course, we get a few more values that is not shown in the data set here, right? It's not shown here, it's not displayed, but that's okay. Up here, it rounded to the 4, but we can see that there is actually a lot more afterwards, right? It's not really 4, it's rounding up. It's really 366211094, but that's okay. All right, so we get that last price. All right, so let's go ahead and create a new cell. And now in this cell, we're going to calculate the daily returns, and we're going to drop and remove any NA values. So I'm going to create a variable called daily underscore returns, and I'm going to set it equal to df adjusted close dot pct underscore change, just like what Google suggested here. There's an implicit 1 here, but I'm going to go ahead and put 1 there. And then I'm going to type dot drop NA to remove any NA values. And then I'm going to add some comments for this. So here I'm just going to type calculate the daily returns and drop and remove any NA values. So that should be good. Let me go ahead and run that. Perfect. I'm going to create another cell. And here we're going to loop through the simulations to forecast the future prices. All right. So for I in range, num simulations, num underscore simulations. So we're going to loop through the 1,000 simulations that we have, right? Because we have num simulations equal to 1,000. And then we have our simulations array, which will be of size num simulations. Okay, so I want to get random daily returns for the forecasted days. Then I want to calculate their cumulative sum, and I want to store it in a variable called cumulative returns. All right, that sounds complicated, but it's not. Let's go ahead and type np.random.choice. All right, so we can randomly select a daily return, and the size will be equal to forecast days, and replace will be equal to true. And then we want the cumulative return. So I'm going to type dot cum sum, and I want to store this in a variable, and I'm going to call the variable cumulative returns. Cumulative underscore returns. All right. So I think that looks good. All right. So next I want to calculate the future prices. So I am going to take the last price, which we got earlier, and I'm going to multiply it by 1 plus the cumulative underscore returns. Okay, and I'm going to create a variable for this. I'm going to call it future underscore prices, and I'm going to set it equal to that there. So that's just going to be last price plus last price times cumulative returns. That's all this equation is doing. So last price plus last price times cumulative returns. Okay, and then I want to store those values in the simulation. So I'm going to type simulation here, or simulations I, and I'll go ahead and put a comma and colon, and I'm going to set it equal to future underscore prices. Okay. All right, so let's go ahead and comment this code. So what are we doing here? We're looping through the number of simulations to forecast future prices. And then here we are getting random daily returns for the forecasted days and calculating their cumulative sum and storing it in a variable. Alrighty. And then here, we're just calculating the future prices. And then we are getting or storing the simulations. Well, we're getting the simulations, but we're storing those future prices into the simulations. So maybe I'll put here storing the future prices in the simulations. Okay, so I think that'll do it. Let's go ahead and run this. All right, that was quick. Let's create a new cell. Okay, so far so good. Now I want to print the simulations. So I'm just going to put a little print statement here and then put simulations inside of it. And let's run the cell to take a look at the simulations. All right, and this is kind of what they look like, these simulations. Of course, there's a lot more in the middle here, and then there's a lot more in between here where we can see these dots, right? There should be 365 of these, and it should be 1,000 rows, right? Or 1,000 simulations. Okay, so that's just what it looks like. Let's create a new cell so I can kind of describe a little better exactly what we're looking at there. So I'm going to put a print statement here. I'm going to print simulations 3, 0, 4. All right, and I'm going to run this. And what are we looking at here? Well, we are looking at simulation 4 and the first 4 values. So let's change this up. Let's put 7 here. Let's run this again. Now we're looking at simulation 4 and the first 7 values. And these are the first 7 values out of the possible 365 values. Okay, so I've typed some comments here. Print the fourth simulation and the first 7 values. All right, and so that's all we're doing here. So one, two, three, four, five, six, 7 values there. Okay, so let's go ahead and run this again. Let's create a new cell. And now in this cell, I'm going to plot the results. All right, so we want to see these simulations more visually. So I'm going to plot the results. We're going to see the simulated future prices. And here I'm going to put AKA all of the simulations. And I'm going to type plt dot figure, and we're going to give it a figure size. We're going to set that equal to 10 by 6. Okay. And then for I in range num simulations, all right, colon, I want to plot the simulation. So I'm going to type plt dot plot, and I'm going to plot simulation I, or at position I. And let's see, why am I getting a squiggly? Oh, I'm plotting simulations with an S at position I. Okay. And then I'm going to give it an alpha equal to 0.25, make it a little transparent there. And then I'm going to give this plot a title. So I'm going to type plt dot title, and I'm going to call it Monte Carlo Simulation of Future Prices. And we can do of Tesla. I like Google's suggestion there of Tesla. All right. And then we're going to give a label, or give the plot a label on the x-axis. So we're going to type plt dot x label, and then put days for the x-axis, and then give a label for the y-axis, which I like what Google has suggested here. For the y label, we're going to type plt dot y label, and then put in price, and I'm going to put a $sign, and then I'm going to type plt dot show, and let's run this and take a look at the future prices. Okay, so there they go. They're all over the place, right? These are some of the simulations. Okay, so now the question is, well, what's a good way to kind of see the expected future price in 365 days, right? So let's create a new cell, and let's get the expected future price. So, or let's calculate the expected future price. So here I'm going to put calculate, and I'm going to create, well, what are we going to do here? We are going to take the mean of all the simulations, and then that will be our expected future price. Okay, so I like what Google has suggested here, except I'm going to change a few things. So I'm going to tab this over. We're going to get rid of the axis, and we're only going to get the last value from simulations. All right, so I'm going to put colon, comma, -1. So I'm getting only that last value. And I'm going to change the name here to be expected underscore future underscore price. And here we're going to finish the comment. So I'm going to put calculate the expected future price. Okay, so we're just taking the mean of the last value of all of the simulations. Okay, and then I'm going to go ahead and put a print statement here. I'm going to put expected future price in forecast days. So I'm putting in forecast days, and I'm going to put days here, just like Google suggested. We're going to round to the last 2 decimal places, and we're going to show the expected future price. So I like what Google put here. We just need to put another right parentheses here, and that should do it. So let's go ahead and run this. And so the expected future price in 365 days for Tesla now is $577.93. And that's pretty shocking, especially considering that the price is somewhere around, in our data set here, the current price, the current adjusted close price was 345.16. And so now we're expecting the price to be about $577. So that's what, 200 more dollars than what we currently have. And that's pretty shocking. Okay. So that's basically it. Thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel, I will leave a link to the Patreon page, which is patreon.com/computerscience, in the description below. Thanks again for watching, and I hope you all have a fantastic day, and I'll see you all in the next video. Bye-bye.